What I'd like to do now is explain this using a graph. And this graph measures potential energy on a scale from high potential energy to low potential energy. And it's important to remember that what we're talking about here is the potential energy of the particular things, the spring, the building, the magnets, whatever. It's the potential energy of the objects in question. So we can consider different potential energy states of these various things that we've looked at. So we have high potential energy states and low potential energy states. So here we can consider the different high energy forms of these things. There's the building, is the high energy form of the building in the rubble. The upright bat and the stretched spring and the magnets far apart are all high energy states. And the corresponding low energy states of all these, the rubble, the bat on the floor, the relaxed spring, and the magnets touching. And so we can talk about changes going this way, high potential to low potential energy, and changes going this way, low potential energy to high, and which are more likely and which are not, and there's a bunch of terms that we need to use to explain these. It'll be very useful in just a few moments. First, there's going this way, from high potential energy to low potential energy. And that is what we've talked about as being the thing that we expect to happen. And there's some terminology for that that's quite useful. Reactions going in this direction, from high potential energy to low potential energy, are what we expect, sort of our normal experience. Buildings might fall down, bats fall over, springs recoil, and magnets come together. In thermodynamic terms, they are spontaneous. They will happen if given enough time. Another way to say that it's favored, that's the reaction, again, is another way to say it's more likely. Finally, it releases energy. And in the case of all of these these examples we had, the energy release looks something like in the building falls down, they get sound and light and heat when it falls down and turns to rubble. When the bat falls over, you heard that clonk, the sound of it falling over, and actually gets slightly warmer. The stretched spring, likewise, releases energy in terms of a snap that you might be able to feel. And likewise, the magnets move together and make that clank that you can hear, and they get slightly warmer as energy is released. In this sort of spontaneous and expected direction, this is the decreasing potential energy, from high potential energy to low potential energy. And we can use the Greek letter delta, which looks like a triangle, to symbolize change in potential energy. In this case is negative. When you're going from high to low, high potential energy to low potential energy, the potential energy has dropped. That's a decrease, so it's a negative. The delta PE, the change in potential energy, is negative. Likewise, we can also consider the reverse reaction, because all of these things are in fact reversible. And this reverse reaction is also worth considering. And as you might expect, going in this reverse direction has the converse of all those various words. It is unexpected for rubble to turn into a building, for a bat on the floor to spring up, become upright, a black spring to suddenly stretch itself out, magnets to fly apart. It is also non-spontaneous, another way to say unexpected. It is unfavored, which is another way to say the last thing, which is requires energy input. If I want to turn rubble into a building, I got to put energy in. I got to do all this work to lift it up, pile it up, rebuild the building. If you want to move the bat on the floor to upright, you have to put energy in to lift it up. The string, I had to pull it apart to stretch it apart. And likewise, the magnets, you need to pull them apart with some force to make that happen. And also, as in the case of the question just before this, for a battery, for example, you need to put energy in to charge it. So a dead battery will be down here, and you have to put energy in to make it a charged battery, etc. And if we want to use our delta notation, the delta PE here is positive.